So in this video, we're going to be dealing with different powers and using exponent laws, but the exponents are going to be in fraction or decimal form. The exponent laws are exactly the same. It just overall it's going to look a little bit different because of this. On top of knowing all your basic exponent laws, you should also review adding, subtracting, and multiplying fractions. So here we have two powers with the same base being multiplied together, so we can use our exponent laws to simplify. And what we're going to do is we're going to end up adding the exponents together. So again, both bases are 5, so we can add 1/3 to 5/3 and get a new exponent. And what I have now simplified is going to be 5 to the power of 1/3 plus 5/3. Now to simplify further, we have to add these fractions together. And we know when we're adding fractions, we need the bases to be the same. They're already the same. They're both 3. So it's nice and easy for us. We're going to add the numerators together and keep the denominator the same. And what we have is 5 to the power of 6/3. And we can actually reduce this even further by just going 6 divided by 3. And we get 5 to the power of 2. In this next example, we have a division of powers. So we have 7 to the power of 1/2 divided by 7 to the power of 2/3. They both have the same base of 7. So we know we can then subtract the exponents to simplify. Now we have a subtraction of two fractions. We need the denominators to be the same. They are not. So we have to figure out what do 2 and 3 both go into. We know they both go into 6. So I'm going to multiply these fractions so I get the denominator to be 6. So I'm going to multiply the first fraction top and bottom by 3. And I'm going to multiply the second fraction top and bottom by 2. And that's going to give me 3/6 minus 4/6. Now I'm going to finish subtracting those fractions. And 3 minus 4 is -1/6. Now we have simplified this expression, but now I have a negative exponent. And to get rid of the negative exponent, we always turn it into the reciprocal. That means we make it 1 over whatever we have, and the exponent will turn from a negative to a positive. And what I get is 1/7 to the power of positive 1/6. And we have now simplified this expression as much as possible. Here we have another expression. We have 4 times x to the power of 3, all to the power of 0.5. So now we have a decimal exponent on the outside of those brackets. We can simplify by applying that 0.5 exponent to everything within the brackets. So remember, it has to be applied both to that x to the power of 3, but also to that coefficient of 4. And what we get is 4 to the power of 0.5 times x to the power of 1.5. Remember, using exponent laws, when we have that bracket, we're multiplying that 0.5 with that 3. And that's how we get that 1.5. 4 to the power of 0.5 is 2. And then we're multiplying it by that x to the power of 1.5. 1.5. And we can clean this up a little bit by removing that multiplication dot, so it's 2 times x to the power of 1.5. Or we can also write this as 2 times x to the power of 3/2. So we're just taking 1.5 and putting it in fraction form. That's the only difference. And our last example is asking us to put the expression, so both powers are in the same base, and then subtracting the exponents. So there's 2 steps here. So I have 8 to the power of 1.8 divided by 16 to the power of 0.3. You might be asking me, how do I get these to be the same base? Well, we know that 8 and 16 can both be rewritten so that they have a base of 2. So that's what I'm going to do. And 8 can be rewritten as 2 to the power of 3. Of course, it's all still to the power of 1.8. And 16 can be rewritten as 2 to the power of 4. And remember, it's all to the power of 0.3 still. Now, we have 2 sets of powers that can also be simplified. So on the top, I see brackets with 2 exponents. So we can use exponent laws to multiply the 3 with the 1.8. And we can do the same thing on the bottom. We're going to multiply that 4 with the 0.3. And I'm going to get 2 to the power of 5.4 on the top, divided by 2 to the power of 1.2. So now we have 2 powers with the same base. That was the whole point of making the 8 and the 16 as having the same base, because now I can use exponent laws to subtract these exponents. Again, you can only do that if the bases are the same. Now I'm going to show my work up here. I'm going to subtract these exponents right away, but you really should be showing me this step. But if we go 5.4 minus 1.2, our final answer is going to be 2 to the power of 4.2. So again, I kind of did the subtraction step all at once, but you should show it to me.